Hi everyone. So I hope that you enjoyed yesterday's video where we introduced long division, and yesterday was quite basic and we went through all the steps from step 1 right through the end, just to show you how if you follow all the steps you will be able to resolve a long division problem. So today we're going to make it a bit more complicated. So we're going to be looking at numbers that are not divisible into whole numbers. So ultimately you're going to end up with remainders. All right, so the example that I have for you, the worked example that I have for you is 6,812 divided by 7. So step number 1, we have to write down our multiplication tables for the small number, which is number 7. So to the right hand side of the page, you're going to be writing the table of 7. Let's do that now. So 1 times 7 equals 7, 2 times 7 equals 14, 3 times 7 equals 21, 4 times 7 equals 28, 5 times 7 equals 35, 6 times 7 equals 42, 7 times 7 equals 49, 8 times 7 equals 56, 9 times 7 equals 63, 10 times 7 equals 70. And we'll just stop there for the time being. That's step number 1. So we're now on to step number 2. Let's now look at the problem to solve. So it's 68112. So 68112 divided by 7. So we start with the first digit and let's see if we can divide the first digit by the small number. So the first digit is number 6. So is 6 divisible by 7? No, it's too small to be divisible by 7. So what we do, just like we did yesterday, is that we have to join the first 2 digits together before we start doing anything with the problem. All right, so that means we join the first digit, which is 6, with number 8, which is the second digit, and therefore we get 68. So what do we do with 68? We have to look at our table of 7 that we've just written and find the closest multiple to 68. However, it has to be a number which is less than 68. So let's go ahead and do that. If we scroll down the list to the numbers on the right of the table, we get 7, 14, 28, 35, 42, 49, 56, 63, 70. So the closest number is actually 70. However, we need to take the one which is less than 68. Therefore, that number is 63. So we circle that number in our table, and then we say 9 times 7 equals 63. Therefore, we bring the 9, we write it above the line, or the top of the line. All right, so that's step number 2. Step number 3 is all about finding the remainder. So before we find the remainder, we have to write 63, because remember it's 9 times 7 equals 63. So we write 63, the number that we've used, underneath 68. And then we try to calculate the difference. So 68 minus 63 equals 5. So we write 5 there. So that's step number 3. Step number 4 is the exciting part, is to bring down the next digit down to the last line. Okay, so the next digit that I have in my big number is number 1. So I have to bring down number 1 all the way down so that it's next to number 5. All right. So we're now on to our next step, step number 5, which is a repeat of step number 2. So what we do here is that we have to look at the last numbers, so which is 51, the number 51, and we have to search for the closest lowest multiple in our table of 7. So why don't we do that? So when we do that, 51 comes just above number 49, and 49 is 7 times 7 equals 49. So let's circle number 49 on our table, and what we do is write number 7 on top of the line next to number 9. Step number 6 is a repeat of step number 3. So what is step number 3? What's the remainder? So the number that we've used before is 49 from the table of 7. Remember that. So we write 49 underneath 51 and we have to calculate the difference. So we have 51, we take away 49. What remains is number 2. So we write number 2 and that becomes step number 6. Step number 7 is a repeat of step number 4. So what do we do in number 4 is we have to bring down the next digit. All right, so what's our next digit? It's number 2, which is the last digit out of our big number. So we bring it down. Let's bring it all the way down to the end. And it actually is now 2 next to 2, so it becomes number 22. Step number 8 is when we start the cycle all over again. So we're now back to step number 2. What does step number 2 require us to do is to find the closest lowest multiple. All right, so we are solving now for number 22. So if we go ahead and look at our table of 7 on the right hand side, we have 7, 14, 21, 28. Obviously the closest number is 21, which is 3 times 7 equals 21. So let's circle 21 and we have to write number 3 on top of the line next to 97. All right, so step number 9 is a repeat of step number 3, which is all about finding the remainder. So to find the remainder, we have to write number 21 underneath 22 first. And then we say we have 22, but we take away 21. How much is left is 1. Let's write 1. Okay. All right, so step number 10, which is supposed to be a repeat of step number 4, is to bring down the next digit. However, in our case, we've used up all the numbers, and therefore there is nothing else to bring down. So that means that the problem is actually solved already. So let me now show you how to interpret the solution. So first of all, we've got our number at the top of the line, which is 973, 973. That's the first part of the answer. However, because we're not left with 0 as our last remainder, what do we have? We have number 1 as our last remainder. So that becomes the second part of the answer. So the full answer is 973, remainder 1. Or you can also say 973, 1 over 7, a fraction 1 over 7. Okay, so that's it. You've managed to solve a problem using long division with a remainder.